Hello and welcome to College Algebra 1.8. I know we're doing this a lot with Chapter 3 stuff, but we just needed somewhere to put this. Chapter 1 was just too big, so breaking it up helps a little bit. Okay. So, quadratic inequalities. Quadratic inequalities work like normal quadratics. So let's say we were just solving this as an equal sign. Well, average factor, what multiplies a negative 12, adds to negative 1, that would be, negative 4 and positive 3. So we could set both of these equal to 0, and we would get values that x equals 4 and x equals negative 3. If I plugged either of those into my equation, I should get an equal sign. However, or equal to 0, sorry. However, I'm actually looking for when these values are greater than 0. So what I can do is I can plot both of these on the number line. And conceptually, if I were to keep going on the number line, this would go all the way to negative infinity. This would go all the way to positive infinity. Well, we can see this actually divides my number line into 3 segments: negative infinity to negative 3, negative 3 to 4, and 4 to infinity. So what I need to do is pick values in those segments. So a number less than negative 3, let's say for the sake of argument, negative 4. A number between negative 3 and 4, so something like 0, and a number bigger than 4, something like 5. What I can do is I can take those values and plug them into the original inequality and see what's going on. So let's say I plug in negative 4 into my original inequality. And I'm going to test if it's greater than 0. Well, negative 4 squared would be 16. Minus negative 4 would be the same thing as adding 4. So 20 minus 12 gives me 8. Is 8 greater than 0? That's true. So I'm going to say this is a true statement for that segment. I can move to the second one. I'm going to test 0. 0 squared minus 0 minus 12 greater than 0. Well, 0 squared is 0, minus 0 is still 0, minus 12 is negative 12. Negative 12 is not greater than 0. So that'd be false for the middle segment. And I can do the exact same thing with 5. 5 squared minus 5 minus 12. 0. 5 squared would be 25. Minus 5 is 20. 20 minus 12 is 8. 8 is bigger than 0, so that's true as well. So now my answer is a representation of everywhere that my inequality was true. So in this case, negative infinity to negative 3 was true, as well as 4 to positive infinity was true. So I'm back to, interval notation. Because I just have a greater than sign, I know these have to be parentheses. Remember, if I have the equal to, that's when I get the brackets. Otherwise, parentheses. And then also a reminder that infinity and negative infinity always have parentheses. Let's try another one. Here we have x cubed minus 8x squared plus 16x. I have a degree of 3, so fundamental theorem of algebra says I might have 3 different answers. So I could end up dividing my segment into 4, or not. We'll see how it goes. Well, I can see that I have an x in every term, so I'm going to factor out an x. What multiplies 16 adds to negative 8? Well, that would be negative 4 and negative 4. So I'm going to get x and x minus 4 quantity squared. I could set this equal to 0, giving me 0. This equal to 0, giving me 4. And I get 4 a second time. I have a multiplicity of 2, which is kind of interesting. So I can graph it on my number line. 0 and 4. Okay, I need to pick a number less than 0, so negative 1. Between 0 and 4, so 2. Greater than 4, so 5. So we can plug in all of those numbers. Negative 1, cubed minus 8 times negative 1 squared plus 16 times negative 1 less than or equal to 0. Negative 1 cubed is negative 1. Negative 1 squared is positive 1 times negative 8 is negative 8. So negative 1 minus negative 8 gives me negative 9. 16 times negative 1 is negative 25. So that means this would be a true statement. Okay. Now I can plug in 2. Okay. 2 cubed is 8. Negative 8 times 2 is negative 16. 8 minus 16 would be negative 8. 16 times 2 is 32. Negative 8 plus 32 would be 24. 24 is not less than 0, so that would be false. And then we can plug in 5. 5 cubed minus 8 times 5 squared. Oh, this should have been squared. Does that matter? 2 squared is 4 times negative 8 is positive 32. Oh, it wouldn't have mattered. I saw positive 8. Okay. Plus 16 times 5. Less than or equal to 0. 5 cubed is 125. 5 squared is 25 times 8. Negative 8 is negative 200. 125 minus 200 is negative 75. 16 times 5 is 80. Negative 75 plus 80 is positive 5. So that would be false here as well. So my true statement would be from negative infinity to 0. 0 needs a bracket because it's the equal to. And interestingly enough, this is equal to 0, potentially. And we know earlier that if I plug in 4, I get exactly 0. So 4 itself is true because of that equal to. So I get a union, and I just get 4 as an additional answer. Another interesting thing with this problem is you'll notice that I had back-to-back intervals that said false. Now, if I flip back a slide, they alternate true, false, true. And if you've ever worked with these before, they typically do alternate. So what's causing this one to be false, false? Well, it's all because 4 has a special feature here. It has a multiplicity of 2. Because that happens, you get the same thing on both sides. If you have an even multiplicity, you'll get the same on both. Now let's experiment. Let's look at this graphically. Well, I graphed this, x squared minus 4x plus 1. We can all agree that that doesn't factor very nicely. Now it says graph when it's greater than or equal to 0. Now mechanically, this 0 is functionally the y value, which should make sense. When I get 0 here for these y values, that often means the x-intercepts. So I just need to know where the y is greater than or equal to 0, aka it has to be above the x-axis. Well, looking at it, we have the two x-intercepts right here and right here, which I did go out and find, 0.267 and 0.373. So from negative infinity all the way to that 0, I am greater than. And from this 0 all the way to positive infinity, I'm greater than. So we would get the interval of negative infinity to 0.267 union 3.73 to positive infinity. Now let's talk about projectile motion. Projectile motion tends to follow this equation right here, that's negative 16t squared plus v sub 0 t plus s sub 0, where s is the height off the ground, usually is the y value as well. S sub 0 is the initial height, kind of like our intercept, or our y-intercept, you want to think about it that way. V sub 0 is your initial velocity, and t is time after launch. V sub 0, your initial velocity, is actually pretty interesting. If it's positive, that means it's being projected up in the air. But if it's negative, it's being launched downward. Okay. So the negative 16 is representative of gravity, so that's always there. So S equals negative 16 t squared. Initial velocity of 288, so plus 288 t. And straight up from the ground, so S sub 0 would be 0. I start with 0 feet off the ground. When will the projectile's height be above the ground be at 1152? Well, there's a couple ways you can go about solving this. This first one we have is S equals negative 16 t squared minus 288 t. And the second one I graphed is 1152 feet. And what we can do is second calc intersect on our calculator. So let's see if I can just do that here quick. Negative 16 t. For anything, I'm just going to use x's because that's how my calculator works. I need to turn my stat plus off though. Let's go zoom 6. Zoom out. Zoom in. Oh, that's always the worst part, is finding the right window. All right, we see that it crosses twice, so I can do second calc intersect. First curve, just make sure you're on one of the equations. In this case, I'm on the blue equation. Second curve, make sure I'm on the red equation. And guess, get as close as I can to the first intersection I'm trying to find. We see that it is 6. I can even go to second table and look for which x values the y values are the exact same. So right there we see it at 6, and again we see it at 12, where they're both exactly 1152. So I see that this is 6 and 12. So the question says, when will it be above ground be 25 feet? Or when will the projectile's height above ground be that? That would be at 6 seconds and at 12 seconds. And then the next question, when will it be at least that? Well, that would include all of these values as well. So I'd get the interval from 6 to 12. And then when will it land on the ground? I'm just finding this value right here. So I'm finding this x-intercept, which would be second calc 0. You end up with x equals 18. Thank you for listening, and I hope you have a great day.